Good morning, everybody. Today we're going to be looking at Chapter 6, Lesson 3. We're going to be talking about um, processing binomial radical expressions. So at the end of the class, you should be able to subtract and add radical expressions. And this is more of the same work as we were dealing with variables. So you'll see it's going to be something really simple to learn. Follow through the uh, the lesson, and if you have any questions, just write them down, and the proctor can pause the video, and then you can ask your questions and make sure you know everything that we're explaining so you can accomplish the classwork today. All right, so let's get started. So the title of the class today is, so we're in chapter 6, lesson 3. We're going to be talking about binomial radical expressions. All right, so binomial radical expressions. Okay, so at the end of the class, you should be able to add and subtract radical expressions. Okay, so to take you from what you do know to what you don't know, let's talk about variables. If you recall, you can add two of the same kind, as for instance 2x plus 2x equals 4x. And the reason you can do that is because the coefficients can be added because you have the same kind of expression, and we call this the like terms. Okay, so we call that like terms because they are alike. For instance, you will not be able to add 2y plus 2x because these are not like terms. So for that reason, this cannot be simplified further, okay? Because these are not like terms. Okay? All right. So that's when we talk about variables. But now we're talking about radicals, okay? And if you recall from further classes, a radical will have the radical symbol and then whatever's inside. Okay, let's identify these things. So that's the radical symbol. Okay. What's inside of the radical symbol? It's called radicand. Okay. And every radical symbol has a number. Okay? That number, it's called the index. Okay? If you don't see a number, you have to assume it's 2. Okay? So these two expressions are the same. Okay? That is not the case with other numbers because you can have any kind of number here. Okay? Etc. Okay? So, two radical terms are like when they are exactly the same in the sense that they have the same number inside and the same number outside. For instance, if I multiply 4 times this expression here, and I have 5 and I have this expression here, I should be able to take these two coefficients and add them together, because the number inside it's the same, and the number outside it's also the same. That means these two terms are like radicals. Okay? And they're like radicals because they have the same index and the same radicand. So these are like radicals because of these reasons. Okay? Okay. So now we're going to talk about a property. This property, it's called combining radical expressions. Okay? Combining radical expressions. Look, just like if you have ax plus bx, and that'll be equal to a plus b times x. Okay? just like when you have the same variable, you can add a plus b. The same happens when you have like radicals. Okay? So if you have the same radical, okay, then you can add their coefficients, and that will be equals to a plus b times the same radical. Okay, so as long as these two guys are the same, then you can combine the coefficients. Okay, and the same applies to minus. Okay, watch. A, this radical, plus b, and this radical, I'm sorry, minus b, right? That will be equal to a minus b and the same radical. Okay? Alright, so let's do a couple of exercises just to get our feet wet. Okay? So this is problem number 1. Okay, so this is adding and subtracting. Radical expressions. Okay, so the question is this: what's the simplified form of the following? Okay. The simplified form of the following. Okay. Exercise A. You got 3 radical 5x to the second, or to the square, minus 2, and then the same radical. Okay? So because they are the same radical, you are able to take the coefficients and combine them and say 3 plus 2 equals 5. That's the number you're going to put in there. So that'll be equals to 5. And then you take this radical, which is the same, and you're going to put it in here. 5x to the square. And then this will be the final answer. Oh, I'm sorry. This was plus, okay? So 3 plus 2, 5, okay? Now, let's do exercise B. You got 6x to the square, and then the square root of 7 plus 4x and the square root of 5. Okay? In this case, the radicands are different. Okay? So the answer to this will be you cannot combine these expressions. Okay? And the reason why you can't combine these expressions is because the radicands are different. They have the same index, but the radicands are different. Okay? Okay, so let's do one more. Exercise C. 12, and then the cubed root of 7xy minus 8, and then the fifth root of 7xy. As you can see here, and here, the radicands are the same. Okay? But as you can also see here, look. The index are not the same. Okay? So the answer to this, it's exactly this answer. You cannot combine it because they don't have the same index. Okay? Let's do one more example just for safety measures. Three x, the square root of x, y, plus 4x, and the square root of x and y. Okay? So in a case like this, the first thing you're gonna analyze are the radicands. Are they the same? Good. Check. Then we're gonna analyze the index. Are they the same? Yes. Check. So that means I'm able to combine these two. Okay? Which is what I'm gonna do. I'm gonna take 3x and I'm going to combine it to 4x, and that's gonna be equals to 3 plus 4x, because you take these two numbers and you add them together. So 3 plus 4 is 7, and then I'm gonna pass this variable next to it, okay? And that's actually my answer. So I'm gonna go ahead and put 7x as the coefficient, and my radical expression, it's 2xy, and then that's the answer. Okay? I hope you understood. If you did not understand, pause the video and ask your proctor, and then you can continue. Okay, so now we're going to talk about simplifying the expression before you add it and subtract it. Okay, so this here is problem 3. Simplifying before adding. Or subtracting. Okay. So the exercise is, or the question, I should say, it's the following. What is the simplest form of the following expression? Okay, this is the expression. The square root of 12 plus the square root of 75 minus the square root of 3. Okay, so what are the rules to combine these expressions? Number one, the same index. Okay, is it the same index? Well, yes it is, because if you don't see a number, you have to assume 2. Check. Second rule, same radicand. Okay, now 12, 75, and 3 are not the same radicand, so we did not pass this rule. The only way we can combine these three figures is if I can make the radicand be the same in every case. So for that, we are going to do prime factorization. Okay, so you are going to take each radicand and you are going to factor it. So two numbers that multiply together gives you 12. It's 4 and 3. 3, it's prime. And then two numbers that gives you 4 when you multiply them together, it's 2 and 2. And those are prime. So 12, it's equal to 3 times 2 times 2. And then you got 75, which is 3 times 25. And 3, it's prime. And then 25, it's 5 times 5. Okay, and those are prime. So this is equal to 5 times 5 times 3. And obviously 3, it's prime. So we're not going to factor 3. Now we got to see what's the greatest common factor in between these three. Okay, what's the number that repeats every time? The number that repeats every time, it's the number 3. Therefore, the greatest common factor is the number 3. Okay? And you got 2 and 2. 2 times 2 equals 2 to the power of 2. And then you got 5 times 5, which is equals to 5 to the power of 2. Okay? Alright, so when you rewrite these expressions after you factor them, the 12, it's equal to 3 times 2 to the power of 2. So I'm gonna put those guys inside of the radicand symbol, like so. Plus, and then you got these two, which is 3 times 5 to the power of 2. And you put those inside of the radical symbol. And then 3 doesn't factor, so we're just gonna leave it as is. Okay? But these two you can break apart, right? Look, this one has the right key, so the 2 gets out and only the 3 stays in. This one, the 5 has the right key, so the 5 gets out and only 3 stays inside. And then 3 stays inside in here, and just as when you see an X and you don't see a number, you put a 1. Then you put a 1 in here, like that. And now we actually comply with the second rule we didn't comply before, because we have the same index and then we have the same radicand. Okay, so this is gonna be equal to 2 plus 5 minus 1. Okay, 2 plus 5 2 plus 5, it's equals to 7 minus 1 it's equal to 6 times 3 to the square root of 3. And this will be the answer. Okay? Let's do one other example of this kind, just for safety measures. Okay, so the third root of 250 plus the third root of 54 minus 16, the third root of 16. And you're gonna do exactly the same thing. You are going to take each radicand and you are going to factor it. Okay, so this is equals to 5, this is equals to 6 times 25. Okay, and 6, it's equals to 2 times 3, and 25, it's equals to 5 times 5. So this is equals to 2 times 3 times 5 to the power of 2. And then you're gonna take 54 and you're gonna do the same. Okay, so 54, it's 2 times 27. Okay, and then this one is 3 times 9. And then this one, it's 3 times 3. And let's just check our math right here. Wait, we gotta fix our factorization here. Okay, so 225 divided by 25. Okay, make this correction. Okay, so 25 times 10, it's 250. Okay, and then 5 times 5, and then 5, it's prime, and then 2 times 5, and then 5 is prime. Okay, now it makes sense. All right, so you got 2 times 5 to the power of 3, and in here it's 2 times 3 to the power of 3. And now you have to do the same for 16. Okay, and that's 4 times 4, and that is 2 times 2 times 2 times 2. Okay, and look what I'm doing. I'm grouping them in groups of 3 because the radical expression, it's the root, the third root. So you gotta group them in groups of 3s, right? So this is equals to 2 times 2 to the power of 3. Okay, and then you do your simplification here. Like so. Okay? And watch. This 2 has the right key. This 3 has the right key. And this 5 has the right key. So at the end, the 2 goes out. And I'm sorry, the 5 goes out. And the 2 stays in. And then the 3 goes out. And the 2 goes in. And then the 2 goes out and another 2 stays in. They all have the same index and they all have the same radicants. Okay? Like so. Okay? So since they all have the same radicants and they all have the same index, now you're able to take all the coefficients and combine them. So you got 5 plus 3 minus 2. Okay? And that is equals to 5 plus 3, it's 8 minus 2, 6. So at the end, this is equals to 6 and the third root of 2. And that's the final answer. Okay? All right. Now let's talk about multiplication of binomial radical expressions, okay? And this is the last problem, and then I'm going to tell you what is it that you got to do for your classwork. Now this is problem number 4, okay? And we're going to be talking about multiplying binomial radical expressions. Okay, and the exercise is this one. We're gonna do 2 exercises. So this is problem A. 4 plus 2 and the square root of 2, and 5 plus 4 and the square root of 2. Okay, so now this is multiplication and these are binomials. Okay, this is one term, this is another term, and that's one term, and this is another term. So for this you gotta use the FOIL method. This is the first, this is the last, this is the outer, and this is the inner. Okay, so the first is equals to 4 times 5, and that is equals to 20. The outer, it's equal to 4 times 4 and the square root of 2. Okay, so when you have that case, you multiply the numbers first. So 4 times 4, it's 16, and then you add the radical, and then enter. It's equals to 2 and the square root of 2 times 5. The same case, 2 times 5 equals to 10. Okay, and then because these two have the same radical and radicand and the same index, you can combine these two and say 16 plus 10, and then you put the same radicand, okay, and that is equals to 26 to the square, all right? And then the last, okay, which is 2 and the square root of 2 times 4 and the square root of 2, okay? So at the end, this is equals to 2 to the square times, well, let me explain it in a simpler way, okay? When you have two radicals, okay, and they are inside of the house, this is what you do. Look, when you have this situation, this 2 cancels that, and this is equals to 2, all right? So you will have to multiply 2 times 4 times 2, okay? So this is equals to 2 times 4, and then this 2 goes out, right? Because it's squared, times 2, okay? So 2 times 4, it's 8, times 2, it's equals to 16, okay? And you can take this number and you can take that number and you can combine them now, right? So you can say 20 times 16 equals 36, okay? So now, after this, you take this part and you combine it to this part, okay? And that is the answer. Okay? That's the answer. So this, the answer to this will be 36 plus 26 and the square root of 2. Okay? Okay, we'll do one more for safety measures. Okay. B. 3 minus the square root of 7 times 5 plus the square root of 7. Okay? And you're going to do the same deal. You're going to use FOIL first, last, outer, inner, okay? And the F, it's equals to 3 times 5, 15, okay? The O, it's equals to 3 times the square root of 7, right? Which is 3 square root of 7, okay? The inner, it's equals to negative the square root of 7 times 5, and that is equals to negative 5 square root of 7, okay? When you combine these two, this is equals to negative 2 and the square root of 7. And then last, it's negative square root of 7 times positive square root of 7, okay? So that is equals to negative 7 because this is to the square, right? And that cancels each other, all right? So now you're gonna take these two and you're gonna combine them together. 15 plus or 15 minus 7, okay? And that is equals to 8, all right? And then you combine these two, this one and that one, okay? And the answer is 8 minus 2 the square root of 7, and that's your answer, okay? All right, so you should have been given, and if not, the proctor will give it to you in a few minutes. You should have been given this classwork. Okay. So I want you to do from 10, 11, 12, 13, 14, 15. Then from 17 through 18. Okay? You don't have to do this part. Don't do. Okay? The only thing you're gonna do it's the yellow part. Okay? Start working on them in a situation like 26 where you see this square over here. All you gotta do is this. All you gotta do is this. Square root of 3 plus square root of 5 times the same. Square root of 3 plus square root of 5. Okay? The same thing. The same goes here. Square root of 13 plus 6 times square root of 13 plus 6. Okay? So start working on that. If you have any questions, ask your proctor, and hopefully when you get it all done, you make sure that you go to your teams. Make sure you go to your teams, and you are going to see in the assignments binomial radical expression, and this is where you are going to submit your calculations and your classwork. Okay, Um, that will be it for today, folks. I will see you as soon as I get back. I hope you have a wonderful, wonderful day.